Hello everyone, welcome to your science class. Today we are going to discuss chapter number 12, Combustion and Flame. In the last chapter we have read about fuels. Burning of fuels produces energy which is used for domestic and industrial consumptions. Some of the fuels like LPG, kerosene, etc. One with a flame, giving off heat and light, while others like coal and charcoal just glow without producing any flame. Why do these substances behave differently? Let us study about combustible substances and their behavior in this chapter. So firstly we will discuss combustion. Burning a substance is actually a chemical change. When a substance is burned in air, a chemical combustion takes place. In chemical change, substance is not wet. The process in which a substance combines chemically with oxygen to produce heat and light energy is called combustion or burning. It is an oxidation reaction since oxygen is added to the substance. The substance which burn rarely are known as combustible substances. Wood, paper, straw, cloth, wax, kerosene, etc. are all combustion substances. In fact, all the fuels which we have come across are combustible. Air or oxygen is compulsory for combustion and ignition temperature is necessary for combustion. And two substances are necessary for combustion and do fire. Ignition temperature, the minimum temperature at which a combustible substance starts burning, is called its ignition temperature. Substances, in fact, all the fuels which we have come across the combustible, since oxygen present in air helps a combustible substances to burn. It is called a supporter of combustion. Oxygen gas is supporter of combustion. Other gases present in air do not support combustion, are known as non-supporter or combustion. We understand oxygen is compulsory for combustion from this activity. Aim of this activity to show that air oxygen is necessary for burning. And requirements to kindle a glass jar and a matchstick. And procedure: light the candles and fix them on a table. Invert the glass jar over one of the candle. Observation: the candle flickers and finally goes off as soon as the glass jar is inverted over it. The other candle continues to burn. Explanation oblique conclusion: the candle placed under the jar goes off because the supply of air oblique oxygen is cut off. When the glass jar is inverted over it, the other candle continues to get a free supply of air or oxygen and therefore keeps on burning. So we are say oxygen, air is necessary for combustion. From the above activity, we learned that when the supply of air is cut off, a burning substance is extinguished. The same principle is made use of when we wrap a blanket around a person whose clothes have caught fire. Other method often used to cut off the supply of oxygen is to sprinkle water or sand or direct a jet of carbon dioxide on the burning substance. All these methods we will discuss later in the chapter. We have seen that some of the combustible substances such as pieces of paper, dry grass, LPG, kerosene oil, etc. catch fire more easily than a log of wood or a pieces of coal. This is because each substance need different amount of heat to start burning at different temperature. The minimum temperature at which a combustible substance start burning is called its ignition temperature. A substance does not catch fire if its temperature is low than the ignition temperature. This is the reason why a piece of wood or coal has to be heated for quite a long time before it catches fire. Combustible substances which have low ignition temperature are known as inflammable substances. Alcohol, petrol, LPG, nylon, fabric, etc. are inflammable substances. Burning of LPG. From the above discussion, we find that the following three conditions are necessary for combustion of substances. First point, presence of a combustible substance. The substance, these are combustors. And second point, presence of a supporter of combustion. Supporter of combustion is air or oxygen. And third point, heat to raise the temperature of combustible substance of to its ignition temperature. Ignition temperature is necessary for combustion. In the absence of any one of the conditions, combustion will not take place. Next, we will discuss types of combustion. Combustion of substances take place under different conditions depending on the rate at which combustion take place. It has been classified into the following types. Point first, spontaneous combustion. Combustion of a substance on its own at room temperature without being ignited is known as spontaneous combustion. Burning of yellow phosphorus is rare. Spontaneous forest fires and spontaneous fire in coal mines are example of spontaneous combustion. Look at this picture. Forest fire. Forest fire is a spontaneous combustion. These are combustion on its own at room temperature. Yellow phosphorus has a very low ignition temperature at 30 degrees centigrade. Thus, when the room temperature is 30 degrees centigrade or over, it catches fire without being ignited. And second point, rapid combustion. Combustion of a substance in which large amount of heat and light are released in a very short time is known as rapid combustion. Burning of coal, wood, candle and hydrocarbon fuels, kerosene, petrol, LPG, etc. are example of rapid combustion. Burning of wood is a rapid combustion. Explosion. It is a type of combustion where high quantity of heat, light and sound are produced with the evolution of a large amount of gases in a very short span of time. Here oxidation of combustible substances take place at high speed, producing an explosion. Explosion of a firecracker. One of firecracker is a explosion. Example of bursting of firecrackers and explosion in coal mine due to rapid combustion of methane gas. And fourth point, slow combustion. This combustion takes place very slowly without any ignition at low temperature. The process produces a very little amount of heat and no light. Rusting of iron and respiration are examples of slow combustion. Combustion of substances may be complete or incomplete depending on the amount of oxygen available during the process. In rusting of iron, iron react with air and water and form rust. This is the example of slow combustion. Complete combustion takes place when the combustible substance burn in sufficient quantity of oxygen. When hydrocarbon fuels undergoes complete combustion, carbon dioxide gas is produced. When the quantity of oxygen available of the burning substance is insufficient, incomplete combustion take place. Burning of fuels is insufficient quantity of oxygen produces the poisonous gas called carbon monoxide. And next point, how to control fire. When a building is on fire, fireman direct. Next point, how to control fire. When a building is on fire, fireman direct a jet of water on the building. Water along with its vapor help to cut off the supply of oxygen and also bring down the temperature of the combustible materials. The principle of extinguishing fire involves the removal of the conditions which support combustion. These are: point first, removal of all combustible substances, and second point, cutting off the supply of air, oxygen, and third point, cooling the combustible substances below their ignition temperature. Since it is usually not possible to remove all the combustible substances during a fire, the other two conditions are taken into consideration. Fire extinguishers also work on the same principle. When a person's clothes have caught fire, a blanket is wrapped around his body to cut off the supply of oxygen. Look at this picture, fireman extinguishing fire. The most common substance used to extinguish fire is water, but it is not used to put off fire and electrical wiring, as water conducts electricity and may uh, electrocute the person causing the fire. Water also cannot be used for fires involving oil or petrol because water being heavier sinks down and oil keeps burning on top. When substances like wood, paper, or other synthetic fabrics catch fire, water is used to extinguish the fire. Electrical and oil fires are extinguished by directing a jet of CO2 stored as a liquid in cylinders under high pressure. CO2 released from the cylinders expands in volume and being heavier than oxygen involves the fire, thus cutting off the supply of oxygen. Dry powders, chemicals like sodium bicarbonate, baking soda, and potassium bicarbonate also act as good fire extinguishers. In the above cases, they undergo thermal dissociation, producing carbon dioxide gas, which is directed on the air. In the most of the cases, the electrical equipment is not damaged when the gas is used to extinguish fires. The conventional fire extinguishers like soda acid fire extinguishers or foam type fire extinguishers are generally used to put off fires caused by burning of oil or petrol. They release water along with CO2 gas and thus are not preferred the extinguishing electrical fires. Student, we have discussed our today class combustion. We will discuss our next video and next class flame. Thank you. Have a nice day.